Now let's look at this question. The question says that a 0.05 kilograms bullet traveling at 500 meters per second horizontally strikes a thick vertical wall. It stops after penetrating through the wall a horizontal distance of 0.25 meters. What is the magnitude of the average force the wall exerts on the bullet? I'll have Jamb 1985. So we have options here given. So from option A to option E. Now let's start solving rather. Let's have this given. So we have the mass here is 0.05 kilograms. The bullet traveling at 500 meters per second. So we have the initial velocity, the velocity the body is moving with, that's the bullet is moving with. So we have velocity, which is initial velocity u, it is 500 meters per second. Now, horizontally strikes a thick vertical wall. It stops after penetrating through the wall. So the moment the bullet struck the wall, it stopped. So that means that our final velocity is 0. So a horizontal distance of, so we have distance s is given as 0.25 meters. What is the magnitude of the average force the wall exerts on the bullet? So we have force is the question we are asked to answer. So now don't forget I said it's a Jamb question 1985. Now to solve this, we look at it closely. We are going to discover that the relationship between force and mass here is F is equals to ma. But from this, you don't have, you know the mass, you don't know acceleration, but you can get the acceleration from the initial velocity, the final velocity, and the distance, because acceleration has a relationship between these three parameters. So what we're going to do is this: we're going to use a particular formula. Now from the third equation of motion, we have v squared is equals to u squared plus 2as. This is the relationship. Now instead of taking time to make a the subject of formula, we don't have to, because that will take our time. So what we just do is this: we just incorporate the values, these values 1, 2, 3 into this formula for us to get our a. So what we're going to do is this: the final velocity is 0, so we have 0 squared equals to let's use a bracket. We have 0 squared equals to initial velocity is 500, so we have 500, which is squared, plus we have 2 times our a, that's what we're looking for. The distance is already given as 0.25 meters, so you don't need to put the unit here. So we just have it, and then what we go is 0 squared is equals to 0, which is equals to 500 squared. If we do 500 squared, we are going to be having 250,000. We're going to having 250,000 plus, now 2 times a is 2a times 2 times 0.25. So what we're going to have in is 0.5a. That's what we will have. So what you do is you collect like terms. That means 0 and 250,000 are like terms. So this is going to come to this way, becomes minus 250,000, 1, 2, 3, 4. Okay. So we have this equals to 0.5a. Now if you subtract this, we're going to have minus 250,000 equals to 0.5a. Now since we're looking for a, we divide both sides by 0.5. This cancels this. Our acceleration is going to be, if you divide this, we're going to have 250 will divide by 0.5. So what you are going to have in is 5. Going to be having 5 times 10 raised to the power of 5 zeros. So we have 500,000. So this is what we are going to be having. Now, mind you, I didn't put the minus here because the minus sign here just indicates that it was a deceleration instead of an acceleration. So we just leave it like this since we are looking for acceleration. Now, you don't need to put the minus sign, the negative sign, so you leave it like this. And don't forget the unit. The unit is meter per second squared for acceleration. So what we do next is we'll now come back to this. So coming back to this, we have F is equals to, our mass is given as 0.05 times our acceleration, that's this one. Let's have it like this. F is, let's have it here. F is equals to 0.05 times 5 times 10 raised to the power of 5. So we have F is going to be equals to, we times this by 0.05. So what we're going to have in is 250 00. So I'm going to have 25,000 Newton. That is the answer to this question. So thank you for watching, and don't forget to kindly like, to share, and to subscribe for more videos. And in case you have any comments, feel free to send it to me. Thank you.